How's it going, everybody? In this video, we're going to go ahead and take a look at our next routing topic, which is known as policy routing or policy-based routing or PBR. Now, the concept of this is actually really straightforward. In the event that you have a scenario where you have to forward traffic out in a specific direction based on where traffic is coming from, how would you do that? The answer is policy routing. So, for those of you that are out there that are familiar with PBR, not Pabst Blue Ribbon, but I digress. The idea with PBR is source-based routing. You heard me right, source-based. Now, why am I emphasizing that? Simple. Because all the routing you have learned up to now, from CCNA, static routing, dynamic routing, default routing, EIGRP, OSPF, BGP, anything in between, what is it that you're trying to reach? It's a destination, right? Well, in policy-based routing, you're routing based off of the source. I've only used this a handful of times in production to solve certain specific use cases, and we're going to talk about how that type of stuff comes into play as we move forward. But I want to make sure that you understand what it is exactly that I mean. So let's go ahead and do a little bit of whiteboarding so that we understand the objects that we need to be aware of. So I'm going to go ahead and make this kind of big. And so the idea is actually really simple. If I have a particular traffic type that I need to send a particular destination, normally you would use the IP route command, and then you have a specific destination. Let's say for a longer match route, 10.1.1.0/24 to 10.1.2.2. That would be a valid configuration, but again, this is destination based. Meaning, this is where I'm trying to go, destination, and this is how I'm going to get there, or my next hop. So, in policy-based routing, we are going to say, where is the traffic coming from, the source, and where am I going to point it, the next hop. So this is built in a couple different layers. We are first going to define a access list. Access list, and I'm going to use a standard ACL. Why am I going to use standard? Why? Well, what is a standard ACL going to match on? The source of the traffic, right? You don't have to do this. This is not required, but it's a good idea. It's more of a best practice than anything else. So I'm going to create the ACL. So I'm going to say, where is the traffic coming from? Let's say 172.16.10.0/24. Okay? That's where my traffic is coming from. Now, I'm going to call this standard ACL. I'm normally going to give it a name. I'm going to give it a name like PBR_ACL, something like that. Then I'm going to go create a route map. Now, you may not be familiar with route maps, and that's okay. We're going to talk about that more in detail when we get into filtering and route manipulation and things like that. It's basically a binding object of sorts. Again, I'm not going to go into a ton of detail on what a route map is right now, but you're going to create the route map, and the route map itself is going to be calling the access list. So we're going to call, say, match the IP address of PBR_ACL. I'm going to set the next hop information to be some sort of value. Let's say the next hop is going to be 10.1.2.2, just for hypothetically speaking. So now I've got my PBR, I've got my ACL configured, I've got my route map configured, I'm calling the ACL from the route map, I'm specifying the next hop value inside the route map. The next thing is to go to the interface level. Now, this is kind of a caveat here. You need to apply the route map to the interface that's going to be receiving the traffic. Okay, so it's going to be, again, where the traffic is going to be entering in from. So if I have let's say I have R1, right? And the source of traffic is going to be 172.16.10. So on this LAN segment is 172.16.10.0/24, right? This is my source. I have a next hop. Let's say I have two different ones. I have one going out this way and I have one going out this way. And this is my preferred path. If this is 10.1.2.2 on this side, maybe this is 10.1.1.2, then I need to make sure I am going to forward traffic appropriately. In other words, if traffic comes from this source address, it's going to be sent this direction. We apply our route map inbound on the inside interface, or the interface that's going to be receiving the traffic. And once we do that, then any traffic that comes from 172.16.10 should be forwarded out this direction towards 10.1.2.2. Now, the cool thing about it is when we go do a show route map, if traffic is being actually policy-based routed, you'll start to see in the counters field, there's going to be some like matches or hits that we're going to see in the route map. You'll start to see this pop up. So let's go ahead and take a look at this on the command line and break down what's going to actually be happening. Let's go ahead and clear the screen, and I'm going to scroll back up. Now if we look at Secure CRT, and I look at something like iOS 6, which is going to be our PBR router, I'm going to do a show IP route. So currently right now I have some routes that I've got learned. I've got the some connections that I've got going on. I've got 164.45, 100.6.45, 12.6. So if I was to ping 100.6.45.45, I can ping that. If I was to ping 12.6.21.21, I can ping that. But let's assume for the moment that I want to be able to ping the interface of XR21, this 200.21.45. I should be able to ping 200.21.45.21, and I can. If I do a trace to it, trace route to 200.21.45.21, numerically, I'm going to go 12.6, I'm going to go this route, right? And there's nothing wrong with that. Now, that's traffic coming from iOS 6. If I go a step back to iOS 5, and let's look at iOS 5 and do a show IP route, I don't have any routes pointing towards that destination. But if I go in here, and I'm going to have to do a couple of minor things. Remember, routing is bi-directional. In order for me to go back to wherever the traffic came from, I must have a route to it. So if I look at XR21, for example, or if I look at router 45, let's look at router 5 real quick. Do a show IP route, you're going to notice that in here I don't have a route to 105.6. So 105.6 does not show up in the routing table, right? So what I'm going to do is on iOS 6, if you look back here, I am running EIGRP, and I've been running EIGRP for a while now. If I show IP EIGRP interfaces, you can see that EIGRP is enabled on gig 2 and gig 3, but not gig 1. So I'm going to go to global config. I'm going to do show run section EIGRP, and we're going to take a look at the configuration. We've enabled EIGRP on a couple of interfaces. I'm going to type in router EIGRP1 and type in network of 100.5.6.0, 0.0.0.255. Okay, now if I go back to router 45 and I hit the up arrow, I now should have a route to that particular destination as soon as it pops up. So show run, in this case here, iOS 45 is not running EIGRP, so that's okay. But I'm going to have to get it squared away to where it will. So I'll go ahead and I'll go in and do show run pipe include IP route. Let me go ahead and pull out these static routes real quick that we've got set up. I'm going to pull these out and I'm going to replace them with EIGRP. So dynamically learned routes will be easier to work with. So I'm going to type in router EIGRP1, network of 100.6.45.0, and then network of 200.21.45.0, same thing. There we go. So now we have that in play. If I show IP route again, I should have the 100.5.6 network right there. And that's what I really need. I need a way back to wherever I'm coming from. Okay, same thing with XR21. Let's go to XR21. He's right here. Let's go ahead and Cisco, show route. We should have a route in the routing table to 100.5.6 network, which we do, which is what we want to see. So now I can begin going along the process of getting this squared away. So on router 6, if we do show IP route, we can see we've got a whole bunch of stuff learned, which is exactly what I want to see. Now, what I need to do is on router 5 is I just need to come in here and create a default route. So IP route 0.0.0.0 0.0.0.0 to 100.5.6.6. So now if I was to say do a ping to 200.21.45.45, or I'm sorry, 21, I should be able to reach it. If I do a trace to that same address, 200.21.45.21 numerically, I'm going to go via 10.5.6.6 to 12.6.21.21. In other words, I am taking this path right here, right, and I'm landing on the router. Everybody tracking so far? Cool. So with that being said, I'm going to go ahead and take it to the next level. I am going to go into router 6, and I'm going to create an access list that says if traffic coming from 100.5.6, it's going to go via router 45. So currently our path is this to get to where we need to go. I am going to change this to be this path instead, using policy-based routing. Okay, I'm going to go ahead and configure that. So I'm going to type in IP access list standard, and I'm going to call this PBR underscore ACL. I'm going to type in permit 100.5.6.0 0.0.0.255. Okay, I'm also going to create route map. It's going to be RM underscore PBR. I'm going to say match IP address in access list in the ACL name of PBR ACL. And I'm going to set the IP next hop to be, in this case here, it's going to be 100.6.45.45. Okay? Now, if I come out of global config and I do a show route dash map, we're going to see that this is where it's set up. So I need to make sure that I apply this to the inside interface. So on router 6, I'm going to go to interface gig 0/1 and type in IP policy route map, and the route map name in this particular case is RMPBR. Okay. Now, I am going to show route dash map, and we can see that the route map has been applied. It doesn't show you here, but if we were to go to, it doesn't give me any detailed information on that. But what I'm going to go do is go back to router 5. I'm going to hit the up arrow and do a trace. We're going to take a different path now. Now we take 100.5.6, right? And then we go via 100.645.45 to 21.45.21. I go back to router 6 and I hit the up arrow. We can see that the policy routing matches 9 packets, 540 bytes. So that means that our policy routing process is working as such. So now our path is taking this direction. We are going this route all day long. Does this mean that I can, if I was to ping the traffic as well, 200.21.45.21 and repeat it 100 times, it'll work all day long. I go back to router 6, hit the up arrow. Now I have 109 packets have been sent that direction. So that is how you do source-based routing, where the traffic is coming from, and I am going to direct it to the destination I need it to go via a different path. Now, what happens if the ACL is disabled or the route map is disabled on the interface? Maybe we take the policy config off of the interface. What happens then? No worries. It simply is going to route the traffic that direction. What happens if the connection between iOS 6 and iOS 45 goes down? What happens then? Now, if I was to simulate an upstream failure. Let's go to iOS 45, and we're going to shut down gig 0/2. So interface gig 0/2. I'm going to go ahead and say shut it down. Okay, now that it's down, I go back to router 6. Router 6 is going to detect the failure here in a couple of seconds because the link has been down. EIGRP is going to send the update in a few seconds and say, hey, there's a problem. We no longer have reachability that direction. We do a show route, IP route. We can see that we can still reach the next hop, but still reach that destination network, but by a different next hop. And if I go back to router 5 and I do that trace route again, I hit 105.6.6, and what should happen is I should be able to reach that destination in the event that there's a failure. Now I'm not doing that, right? But what needs to happen in order for that to work? So in the the floating static routes video, we talked about how you can configure a floating static route, and then if the primary route goes down, you can associate tracking to that, and then you can create an IPSLA instance with tracking, tie the tracking to the static route. As long as the SLA is up, so will tracking. Therefore, you can flip it over and choose a different path, the floating static route. We have to do something very, very similar here. We have to basically create a tracking object, and then we'll add in some reliability. Let's go ahead and take a look at doing that. Router 5, it's going to keep going. We're going to let it go. I'm going to come up here to router 6, come in here and track. We'll say track object 1, and then what we can do instead of pinging reachability in this particular case, we can track an interface. Track one interface, and what interface do we want to track? We're going to say track gig 0/3. Okay? And we're going to say line protocol. Because if we can say, because right now 45's interface is shut down. So EIGRP goes down, but the interface is still up. So normally on a router you would call line protocol, right? And that would check the up-down status of the interface. In this case here, that's not going to work for us because the fact that the interface drivers won't detect a link failure. So in this particular case here, we have to be a little bit unique or creative with our solution. So I'm going to say line protocol, and if we wanted to, we could say carrier delay and say, okay, how long are we going to wait and stuff like that. And that's basically what we're going to do. So I'm going to go underneath the route dash map RM PBR, and I'm going to say 10, and underneath here, and change the IP address. So I'm going to hit the up arrow. I'm going to come back to this guy and change this to be 100.6.45.45 track 1 reachability. I'll go ahead and pull the no out of that real quick, and hit the enter key. So now if I was to do show run section route dash map, what we're doing is we're going to be pinging this address and tracking the line protocol of the interface. So right now I'm going to go back to router 45. I'm going to no shut the interface, bring it back online. So the connectivity will work as expected, and we're finally able to get to where we got to go, right? And I'm going to go back to 45 is now up and running. I'm going to go to router 6, and the adjacency is back up. I'm going to go here, and I'm going to go router 5, trace route. It gets to where it's got to go. Now I'm going to go to router 6, show route dash map. The policy routing is obviously working, but now I'm going to go to, you can see that it's up because of the output. It says it's up. If I go to interface gig 0/3 and I shut this guy down, what will end up happening is tracking will go up to down, the adjacency will go down, and what should end up happening is 5 should now take a different path. It should go directly to the direction it's got to go, which means it's going to follow the routing table next hop. So if we do a show IP route on router 6, if we show IP route here, it should take this path instead, which is the routing table path. And this is one of those things you got to be careful of. you got to make sure that if you are going to be doing high availability, where you're going to have policy-based routing enabled, you need to be able to fail back. The fail back piece needs to come into play in order for it to work the way that we need it to. So there's some things that you need to keep in mind when you're doing this. Now, normally, you can do a simple ping reachability if the IP address is not reachable. So the command that I'm referring to is this right here. If we do show route map and you look right here, if you can't reach this next hop, it's not able to reach where it's got to go. But we also want to track the line protocol. You could also track IP, but what you're doing is it's actually a two-pronged approach. The two prongs are, the first one is going to be, can you ping this interface IP address? This guy right here. Can you ping this IP address? Yes or no? No, I can't. Okay. Maybe this IP address that you're trying to reach is multiple hops away. So I've seen a lot of customers use the infamous quad 8 as their destination IP address, which could be multiple hops away. 10, 12, 18, depending on where you are in the world. I don't recommend you do this. I always recommend the next hop interface. So check the next hop interface, make sure that it is going to work the way that we need it to. And then if this guy goes down, if this fails, you have a backup with the interface. Is the interface up and running? Is the IP address that I'm trying to reach not reachable, but the interface is still good to go, and the next hop IP address for the attached interface, so in other words, is 166.45.45.45, is he up or down? Make that determination. If he is up, go ahead and reroute, because the reachability here is down. But if you are trying to, if you're trying to go out to quad 8 and that IP address is not reachable, but the interface itself, this connection right here, is still good to go, then you need to reroute traffic. So you're going to send the traffic this way versus this way. And this is one of those things that you have to understand the routing logic that comes into play. Now, the last thing I want to go do before we wrap up, okay, and now I'm going to go to interface, gig 0/3, and I'm going to no-shut that interface. So tracking is going to come online. We're going to be good to go there. I'm going to go ahead and trace route to it. Now it goes to where it's got to go, right? Now, if I was to do a ping to that address, it's pinging. That's going to fail really quickly. So let me go ahead and hit the enter key. Let's go back to router, this guy, and say no shut. Or I'm sorry, on this guy here, gig 6. I'm gonna, I no shut it. Sorry, that's my fault. So router 5, he's still pinging. Well, now he's done. So I want to go back over here, and he's taking the path that he wants to. I'm going to ping that again, but I'm going to go to router 6, and I'm going to shut down the link. So it should fail over, and I should be able to reach where I've got to go. You notice the ping failed. Let me go ahead and Control-Shift-6 that. And if we do a trace route this time, we should take the directly connected link. You just have to be tracking the reachability. In the event that the IP address you're trying to reach is not reachable and the interface is down, go ahead and fail over. But if the IP address you're trying to reach is not reachable, but the link is, keep track of line protocol. If line protocol goes down, then you fail over. But if line protocol is still up, you potentially could be block calling traffic. So keep those things in mind in terms of the operations, because you don't want to be tracking an IP address that's way, way, way far away. So again, just so everybody's on the same page here, when you're doing your configuration, make sure you're tracking the next hop IP. Make sure you're tracking 100.6.45.45 or whatever the IP addresses you're trying to reach. Make sure you're tracking this IP and not something like 8.8.8.8 that's 13 hops away, that is being unreachable because of some upstream failure that's outside of your control. I always like to keep my tracking local to something that I can control. If my upstream next hop is down, then and the line protocol is up, take it down. If the line protocol is down, take the link down and redirect traffic to go this way versus going this way. Hopefully that makes sense, but that's basically what it is that everybody needs to understand in terms of the operations to policy routing and reliable policy routing. Again, this is not something that I'm going to see I've never seen a lot of this, and you should not either. It's one of those last-ditch effort, get something up and running as a temporary workaround until you can figure out a better solution, something that's more useful. If you have any questions, please leave a comment in the comment section below. And until next time, guys, take it easy.